So let's see regarding the another type of transposition cipher. This is the key transposition cipher. We have already learned regarding the keyless transposition cipher. So by the name itself, the key transposition cipher, a particular key will be given, or an order, or how to perform the arrangement of the plain text. The particular method will be given, and by using that particular method we have to perform the encryption and the decryption part here. So suppose in this particular example we have a given key. So this is the given key here. So how many cells are here in that particular row. So in this one we have 1, 2, 3, 4, 5. We have five cells here in this first row, and then 5 cells in the second row here. So what does it means? Means we have to convert only 5 letters at a time here. We have to if you are performing the encryption part, first of all you must count the number of cells in the first row, and that particular number of letters will be used for either encryption or decryption here. So in this case it is already given the downward part. The downward part we use for encryption here, and the upward direction we use for the decryption part. For example, these are nothing but the positions of the plain text here. It means there is a plain text having of 5 letters here. Okay, a plain text having 5 letters. This is the third letter, this is the first letter, this is the fourth, fifth, and second, and so on. So what does it means? While encryption, the third letter in the plain text will come into the first position. The first letter in the plain text will come in the second position. The fourth letter in the plain text will come in the third position. The fifth letter in the plain text will come in the fourth position, and the second letter in the plain text will come in the fifth positions here. We are only permitting the positions of the plain text. We are not adding or inserting any other additional plain text here. In that particular given plain text, we are only changing the positions by the help of this given key here. This is the given key. So by the help of this given key, we are only shifting or changing the positions here. Okay, so this downward position, it depends upon the question. It is not restricted that we must always use the downward direction for encryption only. The questions will tell you what to use, either encryptions, the downward positions, or the upward positions for the decryption part here. So suppose we have already given the plain text as enemy attacks tonight. Okay, enemy attacks tonight. So we have count the number of since there are 5 letters, so we just count. We must form a group, and each group must have 5 letters here. So first one, 1, 2, 3, 4, 5. So this is a first group. Then 1, 2, 3, 4, 5. The second group, 1, 2, 3, 4, 5. The third group, 1, 2, 3, 4. So this up to this plain text here. So we add a dummy letter as the Z here. Okay, CSL we use as this one is a dummy letters here. We insert a dummy letter Z. Then we form a particular group of having 5 words each here. So now by using this position, we are performing the encryption part. So how actually you do? You can just write the corresponding letters here in the given plain text. These are nothing but the positions of the letters here for the first letter of this given word only. We are not considering, we don't have any relation with this word and this word here. With this word we don't have any relations with this one. The relation is between the letters in the particular group here. Okay, so what does it says? The third word, the third letter become the first. So the third letter become the first here. Okay, then the first letter becomes the second. The first letter becomes the second. Next, the fourth letter becomes the third. Then next, the fifth letter becomes the fourth, and the second letter becomes the fifth here. So now we have already changed the positions of these particular letters here. That is, we have already generated the ciphertext by the help of the key transposition cipher here. So this is the given key, and this is the directions of the for doing the encryption part here. So similarly, you can perform the encryption for this one also, this one, and this one here. So with a similar process here. So by conventions we always write a ciphertext in capital letter. So we have written the ciphertext in the capital letter and the plain text in the small letter here. So this is the generated ciphertext for the given plain text here. So similarly for a decryption part, you can also do the same method. This is the given ciphertext. You can write down. So by the given key, so the maximum letters is up to 5 letters here. You can form the group of having 5 letters, and then you can consider the upward directions, then perform the same operations what we have done in the encryption part here. So like that you will get, if you perform this one, then you will get the plain text here. So this plain text you can write in the lower letters here. Okay, lower letters you can write the given plain text here. So what is important in this key transposition cipher? In this key transposition cipher, the very important thing is what is the given key and what direction does the encryption points to, and what direction does the decryption points to here. It is not restricted. I'll remind you once again, it is not restricted that I always use the downward position for encryption and upward position for the decryption. It is not restricted to this one. The questions can be anything. Either the decryptions can be downward or the encryptions can be upward, but these two should be in opposite directions here. The only thing is that the direction for encryption and direction for the decryption should be in opposite order. Otherwise, either of them can be in the upward positions, or another one can be in the reverse directions here. This is the only case. So by looking at this particular key size, you must form the groups here. Why we make this 5 letters in the group? It depends upon the key size here. The maximum size is the 5, so we have made a group of 5 here. So there may be some problems, or something happens in the last group where you cannot make a perfect group of having 5 letters. So at that time you can insert a letter Z here. In this particular key transposition cipher example, they have used a dummy letter called a Z here. So this dummy letter is not restricted that you always use the letter Z. You can use any letters X, Y, Z that is convenient to you, but you should make a perfect group of having 5 letters here. Okay, only then you can change the positions. Otherwise you cannot change the positions here. If you don't have this 5th positions or the 5th letter here, then you cannot shift the 5th letter to the other positions here. Therefore, you should make a perfect group of having that particular 5 letters here. Okay. So you can follow such kind of method. You must also remind you once again that in keyless transposition cipher, we simply write the plain text in row wise and read them in column wise, or vice versa. Either you write them in column wise or read in row wise here. But there is no hard and fast rule there. But in case of this key transposition cipher, a particular key directions will be given. For example, here we have given only 5, so it may be restricted. It is not restricted only 5 here. It can be more than or less than 5 here. The only thing is that the size of the given of the given key should be less than that of the given plain text here. Means if n is the size of the given key and m is the size of the plain text here. Size means the number of letters here. The number of n is the size of the plain text. N is the size of the plain text and m is the size of the key here. N is the size of the key. Okay, in this case only you can perform this kind of operations here. Okay, so next we'll go for the hybrid transposition cipher.